we are going to be talking with AP Chem here. Our first unit is on moles and molar mass. This is stuff that we did back in chapter 10, I believe it was. So remember, your mole is your term that's used to describe a group of atoms. It's going to contain, it's actually a number, like a counting unit, like a dozen is 12. Well, this happens to be this many items. Again, very large number, but that's because we're talking about very tiny things. Okay, so you calculate the mass of 1 mole of a substance by using the periodic table to find the average atomic mass for each atom and adding up that total amount off of your periodic table. So how to calculate molar mass? You're going to count how many atoms there are in each formula unit. You're going to find the mass of each atom, multiply the number of atoms by the mass, and then add those things together. So to go from Avogadro's number, we're going to use that to convert between mass and moles. I'm sorry, between moles and number of particles is what we use this guy from. Okay, we use the molar mass to convert between mass and moles. So here's our first problem. How many moles of lead iodide are there in a 25-gram sample? Okay. All right, so we've got a 25-gram sample here. I need to pull this guy down so you guys can see my work. Don't know how to make this bigger. Is it still going to record though? Okay, yes. Good. Okay.
At the top left, it says record.
Okay, good. All right. Okay, so now I should be able to write on this thing and show you how to do this, I hope. Well, this is a little bit different than the way I normally do things. So, all right, so you guys should be seeing this. Okay, good. All right, so I'm supposed to be able to write on this thing. So how many moles of lead iodide are there? We've got a 25-gram sample, so we've got 25. Is that an okay color, or do you want to probably a darker color? Yeah.
Can you do chartreuse?
Oh my God, this was chartreuse. All right, so we've got 25 grams of PbI2. We're going to convert grams into moles. In 1 mole, I'm going to get the gram value off of the periodic table. So I'm going to add up, 1 lead, which is 206.2, 207, my bad. And then I'm going to add up 2 iodines, which are 126 something each. Okay. So I add those up. I end up with 461. I'm going to divide them. How many sig figs are going to be in my answer? 3. It's driven off. Remember, sig figs are driven off of this value right here. Oh, that's an eraser. That's not a highlighter. I was going for a highlighter. Is that a highlighter?
No.
That's a highlighter. Yeah. That's not very good, though. Sorry. So that's 25. There we go. That's better, right? Okay. So I do my math. I come out. I get my 3 sig figs. This is 3.27. And that's going to be what unit? Moles. Okay. It's not per gram because our grams would have canceled. This is just going to be straight up moles of PbI2. Okay. All right, any questions on that problem?
Multiply.
You multiply by what is it?
Oh, no, I'm not sure. Lippy's wrong. I'm just seeing if you guys are paying attention, that's all. Yeah, yep, that's it. How about this? 0.0542.
That makes sense.
Is that better? Okay. See, just making sure you're paying attention. All right, now they want to know how many atoms there are in this. So now I'm going to take this guy. I'm going to continue my dimensional analysis. Okay. So I'm going to create a new picture here so I can have a little bit of room. 0.0542. That's going to be moles. I'm going to then convert my moles into, they wanted to know atoms of lead, right? Okay, I didn't leave myself enough room here. So I'm going to convert moles into what? Into molecules. Okay, and then I'm going to convert molecules into atoms. Okay, because I know in 1 mole, I have how many molecules?
6.022.
Yep, 6.022 times 10 to the 23rd. And in every 1 molecule, I have how many atoms of lead? They're asking about lead atoms. 1. Now, if they would have asked iodine, what would I have done here? I would have had 2 there. Yep. Okay. So now we're going to multiply this by, and this is where my 3.27 was coming at me. 10 to the 22nd, and that's going to be atoms of lead. Good? That work for you? Okay. Next problem. We've got calcium what's wrong? Ask me a question. You guys good?
Just bending.
Oh, here.
Bending like you're round.
All right. We have a sample here. Is point. The amount of digits, or
No, it just shouldn't have been around this 7.
oh,
Should have just stayed 6.
okay, but it's 3 6 6. You're being pedantic. All right. So CaCO3 here. I've got grams of CaCO3. They want to know how many formula units. That's essentially asking you how many molecules. Okay. Now, why do they say that instead of just straight up molecules? Because technically, this is not a molecule. Okay. Molecules are covalent compounds. Is this a covalent compound? No, it's what? Ionic. Okay. So that's why they use formula units. I oftentimes refer to it incorrectly as molecules just because it's easier to kind of think that way. But that's why they're using formula units. They are more correct. than I am. Okay. All right, so they want to know how many formula units there are in here. So I'm going grams to moles and then moles to formula units. Can you combine these into one step instead of, okay? So you could go moles, and then you're going to have 1 mole, and then down here you're going to have 1 mole, and then you're going to go into formula units. Do you see that?
Yeah.
Or you can just take whatever's on the periodic table and go, okay, that's 6.02 times 10 to the 23rd formula units. That make sense? Huh?
We can skip steps.
Yeah.
What did I?
All right, I've got to figure out the molar mass for calcium carbonate. What is the molar mass for calcium carbonate? Hmm?
100.1.
Okay, we took a calcium, we took a carbon, and we took 3 oxygens, and we added them together. Good with that? Okay. And that's going to equal 6.02 times 10 to the 23rd formula units. I don't think I did this right on here. All right, let's see if I can get this one right, Ben.
Give it 10.
All right, so I ended up, how many sig figs in my answer? 1.47 times 10 to the 21st formula units. Remember how to do these?
I do.
Okay, all right. So that takes care of that guy. The rest of that is going to be homework for tonight. Now we're going to start talking about isotopes.
Oh, wait, yeah. I went to the list.
All right, so isotopes. Isotopes, a sample of a pure element that's going to have a variety of these isotopes. Remember what an isotope is it has a different number of protons. It has the same number of protons and electrons, but a different number of neutrons, okay? Remember what your mass number is comprised of. Your mass number is your protons and neutrons. Remember, electrons are so teeny tiny, they don't make that much difference in the mass. I talked to you guys about how if I were to get on a scale and I plucked a hair out of my head and threw it off on the floor, would that make much of a difference in my weight? No, that's what electrons are to atoms, okay? They don't make up that much mass. So it's just the protons and neutrons that we add together, all right? We do a percentage based on the relative abundance. So that's how we determine our mass. So here is a mass spectrum for chromium. We have chromium 50. Notice that all chromium has the same number of protons. That's what determines that it's chromium. The neutrons then are going to vary. Chromium 50 is going to have 26, chromium 52 has 28, and so forth and so on. Here is the mass based on abundance. So here is the abundance of each of those. And if we were to take this and multiply this out of percent form by each of these masses, and then add up those values, that would give us the mass that's shown on the periodic table. Okay? Here is a pictorial chart of that as far as a bar graph to kind of show you those percentages. We can use something called mass spectroscopy, in which we can analyze those components based on their mass. The mass spectrum then is going to contain pure elements and its information. And we're going to read that by looking at the x-axis for the mass, and the y-axis is going to show us the abundance. So again, x-axis shows us the masses, and here are your abundances off to the side. The average atomic mass then can be calculated by using the relative abundance of the naturally occurring elements, and we're going to use this equation. Again, you're going to multiply the mass times the abundance of the isotope taken out of that percent form, and then you add those together. It's the sum of. Okay, so here is a mass spectrum of a sample of a pure element. It's shown. Calculate the average atomic mass of the element and then identify what it is. Okay, so they've shown us here that we have 93.26 of 39. We have 0.01% of 40 and 6.73% of 41. So we need to calculate this and then determine what element it is. Okay, and I think they've shown you how to do that in your packet. They've given you kind of a start on that. Now we need to figure out and do some calculations, okay? All right, so I need to go back to this screen here somehow. How do I do that? Huh? 10? Okay, well, it let me write on here. Yep, okay, so you guys are able to see that. Okay, good. So I need to create a new one of these. Okay, there we go. All right, so we have our first one, we've got 39 for our AMU. We're going to multiply that by out of percent form. So they told us that our percent was 93.26. So if I take that out of percent form, all I'm doing is sliding the decimal. So 0.9326. Multiply that out, I get 36.37. The next one, I have 40 times, this is 0.01%, so that's 0.0001. So that's going to end up being 0.4. And then the last one, we've got 41 times point, and this is where you got to be careful, because a lot of times people will write down 0.6, and it's not 0.6. That would make it 60%.
0.0. Yeah, I know what she's talking.
Okay, there, better?
I already did. I'm talking.
Okay. Is that better, Annie? No, it's not your fault. I'm the one that's making the mistake. I'm frustrated at myself. Better? Okay. Okay. So 0.0673. Okay. And that ends up being 2.76. All right. So then we're going to add these up. I'm going to try. All right, so I ended up with 39.134. Now, I'm going to take that value and I'm going to go to my periodic table. And I'm going to find a mass that's close to this. What's the closest mass to this for the, what element is that? Potassium. So there's your answer. Okay. All right. here's the next problem. We got this rhenium. Is that right? Yep, I'm right. So rhenium, we're trying to figure out the average atomic mass of this guy. They've given us the average atomic mass. It says that there's 2 naturally occurring elements here. Using the information, calculate the percent abundance of each element. Okay, so this is going to require a little bit of algebra. All right, so we know that we have 100%, right? There's only 2 components, okay? So if X equals X plus, I'm sorry, let me rephrase that. X plus Y is going to equal 1 because we're going to take it out of the percentage, okay? We can easily flip it back into a percentage when we need to. So then Y is going to equal what? 1 minus X. Okay, everybody cool with that math? Okay. So now I'm going to make my first one, my 185. I'm going to make that X. So 185.95 X. If I multiply those together, that's going to give me my
184.94.
oh my God. Do you guys just want to do this? Because I think I'm not able to today. Ben could probably do it. Is that better?
Yeah.
Okay. All right. And then I know also that 186.96 Y, and if I multiply those together, those are going to equal 1. That makes sense? Okay. So I'm going to go through, I'm going to do my fancy dancy math here. Okay.
My sister.
I'm getting rid of the Y. I know that, I know this, right? Okay. So what I'm doing is I'm substituting in that for this. Okay.
I got it.
Okay. And we know that all of this stuff added together here, all of this added together is going to equal this. Where did I get that number from? Yep, it told us in the problem that that's what that all adds up to be. Okay, that makes sense? All right, so now all I have to do is solve for X. Okay, so if I go through and I solve for X, you guys should be able to handle that in your algebra. If you want to go home and play with it tonight, that's what X ends up being. Okay, so that means that RE 185 is 37.3%, and RE 187 is going to be what? How do I figure that out? Subtract this from 100, so that ends up being 62.7%. And you got a few of those to play with tonight. I will put all the answer keys out for you. All right. You're going to have to go home and spend a little bit of time with algebra. This is algebra. This is basic algebra.
Why'd you get rid of the y? Like, why?
I subbed in.
We know what y is. It's y equals 1 minus x. And then
I
you do
subbed
y minus
this
x
in.
after you did that.
And I distributed this into that.
What are you pointing at?
I distributed
Wait, no, no.
this into this. So this times 1 and this times x times 1 times x.
You have two x's left.
I have 2 x's, which means that I can end up with, it ends up being like a -2, essentially, right? -2x. And then you distribute this back over to there, it ends up being a negative number. The negatives divide out, and that ends up being your answer. Algebra? Algebra?
Yeah.
Yeah. Oh, I got time. Okay, good. I was worried. We get out of 25. I'm fine. All right.
Well, then you and then you do subtract that, and then you can combine.
All right.
that, and then divide by that, solve for x. Then you get that.
So now we're going to go on to 1-3. We have pure substances here. Pure substance is one that is with a constant composition. Okay, it's either elements or compounds. When you're dealing with compounds, you go with the law of definite proportion, which means the same elements exist in the same proportions. So there's 2 hydrogen for every 1 oxygen with water. It's that way everywhere around the universe. If you've got 2 hydrogens, 1 oxygen, you got water. Okay.
I think this would be so much better if they.
Then you subtract it. You subtract the x.
Well, no,
You're still perseverating about that old problem, aren't you?
no.
I'm moving
This one
on.
doesn't have an x.
What?
I'll help you with it at the end of class. Okay. Let's
I think I'm
move
just
on.
writing
I
it
can
wrong.
do a walkthrough.
I think I'm writing like the problem.
Do you need me to do a walkthrough with you?
No, but.
All right. So we've got our empirical formula. Remember, your empirical formula is the simplest form of that. So for example, when we have glucose here, its empirical formula, we reduce it down. It's in a 6:12:6 ratio here. We're going to reduce that down to a 1:2:1 ratio. Okay? Remember empirical and molecular formulas. So empirical, the first thing you're going to do is you're going to assume that you have a 100-gram sample. You're going to change those percents to grams. Then you're going to divide by the molar mass to get it into moles. Divide by the lowest mole value, and then you might have to multiply by a factor to get it up to a whole number. The values that you get from D here end up being the subscripts for the element. Molecular formula, then you're going to divide the molecular mass by the empirical mass, multiply the subscripts by that value then. All right, here we go. We've got sugar, and we're going to figure out our percentages here. So I've got Where is my PowerPoint? Here we go. Oops, that's wrong. Ugh. I got too many screens going on here, guys.
What happened to
Sorry.
your little, like, pen?
I left it at the house, so I'm struggling today with a Chromebook. And that's, yeah, I am definitely struggling here, you guys. I'm sorry.
You could use this one.
My smart board, I cannot write to it. I can't touch it. I can't do anything. All I can do is project to it. That's the only thing that it works.
Have you tried unplugging it fully?
It doesn't matter. I've tried everything. It's broken. They won't replace it because we're getting new ones, and I'm just
Did you
kind of
know that
stuck.
we're the only school that doesn't?
No, we're not. They don't have them at Edison yet. They don't have them
Well,
at
Parker has them.
Franklin yet. Yeah, Parker has them, but we don't. Okay, moving on.
So,
Let's get over to our little jam board here. All right, so we are going to first assume that we have a 100-gram sample. We are going to take then our materials here, and we're going to divide them by their molar mass. So I'm going to take 40.0. I'm going to divide it by 12.0 because this is carbon, and I got that 12 off of the periodic table. Wait, no,
oh,
what? Is that the answer? Is that what you're trying to tell me? Oh, yeah. I just round it to the 10th place. It's fine. So that ends up being, I divide it by, so that ends up being 3.33. Then I've got my hydrogen. Hydrogen's easy because it's always divided by
uno.
1. So that's 6.70. And then I'm going to do 53.3. And I'm going to divide that by 16.0. And this is going to end up being 3.33. All right, next step then. We are going to divide by the lowest mole amount. I don't like that blue. There we go. So everything gets divided by 3.33. So this ends up being 1, this is 2, and this is 1. So that means that I have 1 carbon, I have 2 hydrogens, and I have 1 oxygen. So that is my empirical formula. Now we need to calculate the molecular formula. So I'm going to take the mass of this. I'm going to take a carbon, 2 hydrogens, and an oxygen. I'm going to add those together. What does that end up being? 12 and 2 is, plus 16 is 30. Okay? So I'm going to take my, they told me 180. I'm going to divide that by 30. And that is what? Cancel my zeros out. That's 6. So now I'm going to multiply each of the subscripts by 6. So it's C6H12O6. That's my molecular formula. Remember how to do those.
Where did the 180 come
The problem that said the molar mass of the compound is 180.
from? Okay.
All right, one more problem. Okay, so we've got carbon, we got 56.5. I'm going to divide that by 12. We have 7.11. I'm going to divide that by 1. And we have phosphorus 36.4. I don't have that one memorized. Huh? 31? Okay.
Yes.
All right. So this guy comes out to be 4.71. This one ends up being 7.11. And this one ends up being 1.17. What do I do next?
Divide the 1.1.
Right, divide by the lowest mole amount. This one ends up being 6, and this one ends up being 4. So my formula for this guy then is C4H6P. All right. We have a molar mass of 170. We're going to divide that by the molar mass of this off the periodic table, which is 84.97. That's 2. So now we're going to multiply each thing by 2. And that ends up being our molecular formula. You have 1, 1, 1, 2, and 1, 3 for homework tonight. It is not a lot. 7 and 4 is 11. 11 and 7 is 18 problems. And some of these won't be that bad, like they'll go fast. Yeah, well, you're wrong.
Oh, Maddie Russell's as well.
Oh, cool. Howdy.
My boss at